Okay, so we know the rational root test, we know the conjugate pairs theorem, we know the factor theorem, we know the remainder theorem, we know how to do long division. Now I'm just going to solve out a polynomial using all of those tricks so you guys can see how we kind of put them all together. So suppose we have x cubed plus 2x squared plus 4x minus 7. I want to find the zeros of that. I know there's 3 of them. So I start saying, 1, 2, 4, and 7. All my coefficients are integers. Rational root test applies. So P has to be a factor of the constant. The only factors of 7 are plus or minus 1 and plus or minus 7. Q has to be a factor of the leading coefficient. The only factors of 1 are 1. Now I find all possible P over Q's, which in this case is going to be plus or minus 1 and plus or minus 7. That means there's 4 potential rational zeros. Now I plug them all in. I'll start with 1. If I plug 1 in, I get 1 cubed plus 2 times 1 squared plus 4 times 1 minus 7. 1 cubed is 1, 1 squared is 1 times 2 is 2, 4 times 1 is 4 minus 7. 1 plus 2 is 3 plus 4 is 7 minus 7, which is 0. That tells me that 1 is a 0. Or x minus 1 is a factor. I could keep trying my other rational zeros, but instead, I'm going to use our other trick. Now that I know x minus 1 is a factor, I'm going to divide this polynomial by that factor. And I get x cubed plus 2x squared plus 4x minus 7 divided by x minus 1. Again, I'll go through this a little bit quickly because you guys know how this division works. What do I multiply x by to get x cubed? X squared. X squared times x is x cubed. X squared times negative 1 is negative x squared. Switch the signs, negative, positive. X cubed minus x cubed is 0. 2x squared plus x squared is 3x squared. Bring down the 4x. What do I multiply x by to get 3x squared? 3x. 3x times x is 3x squared. 3x times negative 1 is negative 3x. Switch the signs, that becomes negative, that becomes positive. 3x squared minus 3x squared is 0. 4x plus 3x is 7x. Bring down the negative 7. What do I multiply x by to get 7x? 7. 7 times x is 7x. 7 times negative 1 is negative 7. Switch the signs, that becomes negative, that becomes positive. 7x minus 7x is 0. Negative 7 plus 7 is 0. I knew that was going to be 0 because I know x minus 1 is a factor from over there. But now I've taken my cubic and I've turned it into a quadratic. Now I'm going to solve that quadratic and get 2 zeros. To solve it, I go with the quadratic formula. I'll go with green. I haven't used that yet. So you can try to factor that. 2 numbers that multiply to 7 that add to 3 isn't going to work. So quadratic formula. Negative 3 plus or minus the square root of 3 squared, which is 9, minus 4 times a, which is 1, times c, which is 7, all over 2 times 1. So I get negative 3 plus or minus the square root. 4 times 7 is 28. 9 minus 28 is negative 19, all over 2. That's a complex number, so we can rewrite it as negative 3 over 2 plus or minus the square root of 19 over 2 times I. We get two complex numbers here, negative 3 over 2 plus root 19 over 2i, and negative 3 over 2 minus root 19 over 2i. Conjugate pairs theorem says these things should come in pairs. But now the ultimate goal was to find the 3 solutions to that, and I found them. 1 is a 0, negative 3 over 2 plus root 19 over 2i is a 0, and negative 3 over 2 minus root 19 over 2i is a 0. Essentially, that is how this is going to work. You're going to start with a polynomial. You're going to make sure you have integer coefficients, apply the rational zeros theorem, find all potential rational zeros, plug them all in. I stopped after I got one of them because then I knew, oh, I can do the division, which is what you'll do. Then divide in, turn my cubic into a quadratic, then apply the quadratic formula to solve that out, and then I get all three of my zeros. If this was higher order, if it was 4th degree or 5th degree, you could probably check all of these and find other zeros, and then do your division multiple times to keep on dividing down until you get it to a quadratic. Because once we get our problem to a quadratic, we can go into the quadratic formula and get our solutions. This is how you actually want to be able to solve them. Applying all the different theorems. Factor theorem, remainder theorem, conjugate pairs theorem, rational root test, doing your long division. You want to be able to do all of that to actually find all the zeros. We are going to practice this in class with some of your labs.